Can we debug an Arduino? Or what about an ESP32 with an Arduino code running? What is real debugging, and what is debugging anyway? If you think that placing a serial print in certain parts of the code means debugging, well, you are wrong. The code doesn't stop, we have no checkpoints, and we can check the rest of the registers while the code is waiting. In this video I want to show you what is to debug a code and how to do it with Arduino and ESP32. So guys, let's get started. Do you want professional PCBs like these ones that look so good? Then use the services of PCBWay. You can select the board size, any solder mask color that you want, including some exotic purple, or if you want, the matte black and green. You can select the thickness, and the PCB could be from 2 up to 14 layers for some more complex designs. The finish quality is so good, and if you want better connectivity, you could also select the gold finish for your pads. The ordering process is so easy. Just go to PCBWay.com, quote now, insert your design settings and the amount of PCBs, upload the Gerber files, and order now and receive the PCBs in just a couple of days. What's up my friends, welcome back. These are the Arduino Uno and the Nano. And if you go to the Arduino official page, you can see that the IDE 2 can support a debugging tool, but only for these models of Arduino. And let's be honest, we normally use the Nano or the Uno, right? Honestly, I never use any of these models, so how can we debug the Arduino Nano for example? Also later we'll see the same but for the ESP32, because lately I'm using this microcontroller more and more. But first, what parts does a debugging process need? On the Arduino page they recommend you to place a few serial prints around your code and print the values on the monitor. But that's not debugging. When I was building my drone for a university project, I was using the ESP32 and programming C++ using Code Composer. We had a full debugging tool, and such a tool will need to have the ability to add breakpoints, stop the code on a particular part, check all the registers when the code is on pause, resume the code, jump to the next part, and so on. Basically control the code and all the values, the registers, the operation results, and the pin states of any given moment. To do that with Arduino we will use the Visual Studio Code software, which is free from Microsoft. So go to this page and download it and install it afterwards. Once installed, open it up. And first we need to go to extensions and search for platformIO. Click the install button and wait for this extension to be installed. Then you need to restart the Visual Studio Code program. At this point connect your Arduino to the USB cable and check the COM. In my case this will be the COM number here, so remember that. Now that the extension is installed, we click the alien head and open platformIO. Click open and here we click the create new project button. We give it a name. As for the board, we select the Arduino Nano and the framework will be Arduino. We click finish and that will open the INI tab and the Explorer on the left. First we need to edit this INI file with our configuration. Since we've selected the Arduino Nano board, this already has added these 4 lines of code for the configuration, representing the board and the framework. But we need 3 more lines. We need to add the debug tool, the COM of the Arduino, and an extra library. For that you copy from the tutorial page these lines of code and paste them here in the INI file. The only thing you might need to change is the COM port. In my case is this one, but your Arduino might connect to a different COM number. Also by writing just COM like this, it didn't work. I had to add a double slash, then a dot, then a slash, and then the COM like this. And then it worked. Finally with this line we add this library by JTAG. Okay, so the INI file is ready for the debug process. Now we can check the code. Open the source folder and here we open the main file. And as you can see, this is the typical Arduino code. The only different part is that we have to explicitly include the Arduino library because this is platformIO and not the Arduino IDE. You can delete the example function. Next we need to add these two lines for these libraries, because we need them. And one last step, very important. On the first line of the setup loop, we need to add debug init to start the debugger. And it needs to be on the first line. And now we can add our code. Let's try a blink example. So now as you can see on the side, we are able to add these red dots. And these are checkpoints, and the code will automatically stop here where the checkpoint is added. Let's add for example 2 dots. To run the code you can press the play button or directly press F5 on your keyboard. This will upload the code and start the debugger. It will open this wiring file, but you can close out of that. So as you can see, now we have the debug tool for pausing the code, step over, to stop, and so on. And as you can see, the first red dot is now an arrow, marking that the code stopped at that checkpoint. You could also see that the LED on the Arduino is now off. I press the resume button and it will stop at the next checkpoint. But now the LED is on, so we can see each part of the process step by step, and this is very useful. Now let's create a new variable called x. And in the code I increase this variable each loop. Run the debugger once again. In the watch window we add the x variable and see its value. After each loop its value increases, so we can see step by step how this variable changes its value. So that's how to properly debug an Arduino code. Have in mind that if you use external libraries, such as for example this one for the OLED display, you can add the checkpoints inside of the library code, because that's external to the main code. Okay, but what about the ESP32 running an Arduino code? Well, we can debug directly using the USB connector in this case. For that we need an external JTAG programmer such as this one. But first we need to prepare it. Connect it to your PC, and it should automatically be detected. If not, you should download and install the FTDI driver from this page. Then you have to go to this website and download the JTAG software. Install it and open it up. And here select the RS232HS and replace the driver, so now it would act as a debugger. Now we connect the programmer to the ESP32 on these pins. In platformIO once again you create a new project, but now we select the ESP dev kit board. And that will create this ini file with these settings. But on top of that we add these new lines for more settings. Remember to add the COM port of your programmer, because it might be different. Now once again press F5 and just as before, debug your code. And that's how you debug a code for the Arduino or ESP32. I hope that this will improve your codes and find any small problem. Check more information on my website with more details. Thanks again and see you later guys.
Hey guys, so as you all know, making these kind of videos is not that easy for me. It requires a lot of time, a lot of machinery, and also oscilloscopes, power supplies and so on, and also a lot of modules. And thanks to your support on Patreon, it's a lot easier for me to buy those modules. So thank you very much to all my patrons, and also to you guys for commenting below, for giving likes to my videos, and also sharing my videos to help spread out this information. So thank you very much.